Today we are going to talk about finding the mean with and without an outlier. So an outlier is a value within my data set that is either much greater or much less than the other values within my set. Today we will see how that outlier, being so different from the rest of our data, could impact our mean and what to do when that happens. So we've got a table here that shows us the heights of Shetland ponies. Those are like those little ponies. Shetland ponies. We have a list of their heights. So I'm going to start by putting them in order. If I want, I could make a dot plot to help me see this. For now, I'm just going to make a list. So I start with my lowest, and my lowest here is 28. Next, I have 37, 37, 38, 38, 39, 40, 40, 40, and 42. So as we can see, as we start to look, we see that 37 through 42 are all close together. They go almost numerically in order. They're close together. This 28 right here stands out from the rest. That pony is a good deal shorter than the other ponies. So we need to determine if including this pony height is going to be the best representation of our data. So we're going to start by finding the mean like we normally would with that outlier included. So I'm going to add up all of these, 28 plus 37 plus 37 plus 38 plus 38 plus 39 plus 40, 40, 40, and squeeze in there 42. Okay, I divide that, remember, by the total number of data points that I have. In this case, I have 10. Okay, so I get out my calculator, I find the sum of these, getting me 379 divided by 10. When I find that mean, dividing 379 by 10, I get 37 and 9/10 inches as my mean. Now remember that our mean should be representing the center of our data. So this with the mean is telling me 37 and 9/10 inches is the mean. All right. Then we go ahead and take that 28 out. So we add up all the rest of our data points, combine them all, squeeze in that 42, but this time I have one less data point that I'm using. I'm only using 9 of the points because I got rid of that 28. So I divide that all by 9. All right, so I add these all up and I get a sum of 351. And I'm going to divide that by my total number of points, which in this case is 9. When I simplify that out, I've got 39 inches. So when I have the outlier, my mean is 37 and 9/10 inches, and with the outlier, it's 39 inches. So I need to decide if having that outlier included is going to impact my data. So as we can see here, these numbers are actually very close. In some instances, the outlier won't make much of a difference. In this case, I like to go ahead and take a look at this number right here, 37 and 9/10 inches. And I kind of like to place it where it would go. So a dot plot or a number line might be useful in this situation, but I know that this mean goes right about here, whereas this mean goes right here. Now, I can see that this number is only greater than 3 out of my 10 data points. And I want my mean to represent center as best as possible. Whereas that 39 in this case is more center. It's kind of in the middle of all those data points. It's more typical. So in this case, when we have the outlier, it is less than all of my data points except for 3. That means without the outlier in this situation shows me a better representation because it is more centered. It is more accurately in the middle of my data points. Now, sometimes, like I said, that outlier won't make much of a difference. And so you can use either one with or without, but definitely double check for outliers and see how they impact your data.